Okay, so last time we have checked out transport layer, if you recollect. So we have transport layer, reliability, segmentation, error correction, acknowledgements, windowing, sliding window, all these functions. We checked it out. Then after that we checked out flow control concept. So I have given example of IRCTC railway server. uh, then after that we checked out the port number concept. So I told you that if you are browsing, let's say Google, and at the very same time you started downloading something from the Google, so there will be two streams. Those will be sending the data from google.com to your machine. At that point of time, to identify these two streams, that is the segments that will be receiving, to identify what is there inside that segment, so we are having this concept called as port number. So sender, that is google.com, if it's sending the browsing data, it's going to put port number 80, that is HTTP. If it's sending the file data, then it's going to put port number 21 inside that segment. Accordingly, my machine is going to understand, it's going to read the port number, and it's going to hand over the data to the related application. Okay, that is browsing, that is browser, or the file that's getting collected. Right. Then I told you that how port numbers are really important if you consider the security part of it. So security part of it, that is, I told you that in a machine we are having 65,535, you can consider as windows or doors. Until unless you open the application on that machine which works on the specified port number, it's not going to open the port number. Once you start, let's say browser, it's going to work on port number 80, so it's going to open port number 80, and then and only then the data from outside can come inside the machine. So by default 65,535 ports, all of them are closed for the business. As you open the application, as you install the application, as you open the application, the related doors or ports will be opened and the data will flow through it. Okay. Then I explained you the concept of firewall also, how corporate firewall works. So it's immaterial of what ports you have open in your machine, but the corporate network will be having firewall at the boundary, where firewall will allow specific ports only, and only data from that specific ports will be coming inside. Now we'll move ahead and we'll check out the next layer, that is session layer. Now to explain session layer, I will consider yesterday's example only. Let's say I'm browsing. So I'm browsing google.com. So this is google.com server. So a browser is open. So it will be sending a request to google.com. Google.com will be responding back. We know the port number in this is going to be port number 80. It's going to be HTTP request. But let's say within that, within google.com, I have opened my inbox of my Gmail account. So this is the inbox of my Gmail account. So what's going to happen? So let's say I clicked on the Gmail and I'm having 3 new emails in my inbox. So typically everyone knows that what we do, we right click on that new email and we click on open in new window or open in new tab. So there will be another tab or window open which will have my new email inside it. Then second email will be open in another tab, third email will be open in another tab. In short, right now my browser is having total 4 tabs open. This was the original tab, that is inbox. Then I am having first mail, second mail, and third mail in the respective tabs. Now just imagine, Google is sending the data, so the segments are coming to my machine. If you check out the segments, all of them will be having port numbers only, and that port number is going to be port number 80. Now the problem is port number 80 means browser, that is Google Chrome. But within that also, now we are having 1, 2, 3 and 4 options, that is first inbox window or tab, then the first email, second email and third email. So if you check out, port number is going to be port number 80 But within port number 80, that is within browser window, we are having 4 tabs open at this point of time. How it differs from the previous concept? Previously we said that there is a browser going on and plus there is a file that's getting collected. These two are different applications. But right now what I'm talking about, we are having multiple windows of the same application. It's a browser only. So everything is communicating with port number 80, that is HTTP. So within HTTP, I am having 4 sessions going on. How to bifurcate this session? And this is the only point where session layer comes into the picture. So every tab, if you check out the URL bar of this tab, the URL bar will be having www.gmail.com/inbox ? / some garbage set of characters will be there. Observe this set. This particular set is going to be different from the set of or URL bar of tab number 1, sorry, email number 1. Similarly, email number 2, its inbox, that tab will be having a different URL bar. Similarly, email number 3 will be also having different set of characters in the URL bar. These characters represent the session. It's a session ID. So session ID for the first window is going to be different. Session ID for the second window is going to be different. Third window is going to be different, and fourth window is going to be different. So whenever it will be sending a segment with port number 80, within that particular segment, I can say that inside will be having a session layer header. And this session layer header will be maintaining session ID. So according to that ID, the internal data will be handed over to the respected tab. So if multiple windows of the same application are open, then the data will be bifurcated to different tabs according to the session layer header, that is session ID. Now consider that this is not the only case which works in transport layer or session layer. If you recollect, when we studied the frame architecture, we know that frame is having destination MAC, frame is having source MAC, then we are having options field, and then we are having CRC. So this was data link layer actually. So within data link layer, we are having this field. If you recollect, this field was called as options field. What it identifies, if you recollect, I told you that it's going to identify that whether there is a IP inside, or whether there is a IPX protocol, or whether there is a AppleTalk protocol, or whether there is a CLNS protocol. So it's going to identify what kind of data it is having inside. So according to this options field, the internal data or internal packet will be handed over to the related logic. If it's IP mentioned in the options field, the data will be handed over to the IP logic. If it's IPX datagram, then datagram will be handed over to the IPX logic. So you can say that at data link layer, options field is there to identify what kind of entity it is carrying, what kind of network layer entity it is carrying. So let's consider that network layer entity. We know that everywhere we are using TCP/IP. So let's consider that we are having IP packet inside. So IP packet, according to options field, it's taken out. Now please remember, IP packet, we have seen that header is source IP and destination IP. This is the header. Also understand that inside this IP packet, there is one more field called as protocol number field. This protocol number field identifies what kind of protocol it is carrying for the transport layer. So for the transport layer, we know that there can be TCP segment. Also there is one brother of TCP which sits at the transport layer called as UDP, user datagram protocol. Soon we are going to check out what's the difference between TCP and UDP. But yeah, at transport layer we are having two protocols. One is TCP and one is UDP. So inside IP packet, protocol number is the field which will identify that whether this packet is carrying TCP segment or whether this packet is carrying UDP segment. For TCP, protocol number is 6. and for UDP protocol number will be 17. So this protocol number field will identify what kind of transport layer protocol it is having inside. And now we came up to the transport layer, where I already told you that within that we are having this concept called as port number. So port number is going to understand and it's going to bifurcate the data to the upper layer, and if it's port number 80, the data will be handed over to the browser. And then session layer is going to understand that within browser which tab, so accordingly it will be handed over to the related tabs. In short, what I'm trying to tell you is every layer is having a field inside, a mechanism sitting inside, which will identify where to hand over the data to the upper layer. So data link layer is having options field, so that it will identify network layer protocol. Network layer is having protocol number field, which will identify transport layer protocol. Transport layer is having port number concept, which will identify the upper layer application or the protocol, that is HTTP or FTP. And then within that particular protocol, if there are multiple tabs, then session layer comes into the picture. So the mechanism is all set right from the data link layer. Remember, I am explaining in the opposite direction, that is with the perception of decapsulation. But when sender sends it, actually all these things are put together by google.com while packaging it. If it's a email number 1 and its data, then session attached ahead of that will be that particular session number 1. Then this particular chunk goes to the transport layer. Transport layer is going to attach its own headers, where it will be putting port number 80. Then transport layer will be sending it to the network layer, where network layer source IP destination, and besides that it's going to add protocol number 6, that is it is working with TCP. Then it will be handed over, that packet will be handed over to the frame, where frame is going to put the options field, destination MAC, source MAC, and options field, where options field will be mentioning that there is IP inside this, and then it will be forwarded in bits. So sender is going to send it accordingly, and receiver is going to receive and decapsulate accordingly. But the mechanism is there on every layer. On data link, options field. On network layer, it's protocol number field. On transport layer, it's port number field. And on session layer, it's session identifications. I hope you are clear with this. So this was what you can say, the session layer. Most of the times it is said that session layer does not exist. This kind of mention comes into many books. Please remember, session layer comes into the picture where application allows to open multiple instances. If application allows multiple instances to get opened, then and only then session layer comes into the picture. Old applications, they have only one session. So what happens is, even if you open multiple windows of that application, everywhere you will be receiving the same thing. So everywhere the window will be same, the data inside that will be same. But the best example is the browser itself. You open Google Chrome, you open multiple tabs within that. Every tab will be having a separate kind of data. It will be having a separate session ID, even though you are browsing the same Gmail. So that's the best example that I can give to you for the session layer. Now coming to the two protocols of transport layer, TCP and UDP. The basic difference between TCP and UDP is TCP is reliable, UDP is unreliable. So whatever I mentioned about the transport layer and all these terms, reliability, segmentation, error correction, acknowledgements, windowing, sliding window, everything is there inside TCP. So all these fundas are there inside TCP. So it's having reliability, it's having error correction, it's having acknowledgements, and UDP doesn't have anything out of this. So what's UDP? UDP will just package the data, put the port number, and will send the segment. It's not going to wait for the next segment. Sorry, it's not going to wait for the acknowledgement. Immediately after packaging this, it's going to add the next segment, it's going to send that segment. So it will continuously keep on sending without waiting. It doesn't have any kind of timers, it doesn't have any kind of acknowledgements. So what's the difference? Ultimately UDP is going to be very fast. It doesn't wait for any kind of acknowledgement, doesn't have any kind of timers. And TCP comparatively it's going to be slow. Okay, so you'll be saying what's the use of being a fast if it's unreliable? Nowadays I would like to tell you that most of the links are very reliable links. So more and more communication on the internet is going on UDP. So even if you keep on sending without having any timers, without any error correction, without any acknowledgements, still most of the times it reaches to the destination reliably. So that's why more and more streams are becoming UDP based. The best examples that I can give it to you, like if you are sending an email, so emails has to be reliable. The data inside email should not be lost. So that's why I have to use TCP. But if you are watching, let's say live streaming, live T20 match. So talking about live streaming, if a bowler is starting to bowl on, and let's say you are sending, that is that server sends 3 segments and waiting for the acknowledgement. So what you will see? You will see that bowler starts on, again holds on. Okay, the entire picture will be pause. Again bowler steps 2-3 steps, again it will be pause because it's waiting for the acknowledgement. This doesn't give me live streaming. There will be a huge delay. What I want is in between, if I see a bowler skipping up the steps, some frames are damaged, some segments are lost, still that's okay. I want to watch it live. That's my concern. So if this is my concern, I have to move on with UDP because reliability is not my concern. My concern is the speed. So in that case, we have to use UDP. TCP is not going to help out in that case. So this is the way how there are 2 protocols which are going to work at the transport layer. If you want reliability, if you want error correction, acknowledgements, it has to be TCP. The data is important, it has to be TCP. But if data is not important, but the speed for that data is important, then it has to be UDP. So TCP and UDP, both the protocols are working at the transport layer. Yeah, one more thing, TCP has flow control. In addition to this, the second concept that we learned during our previous session. So flow control is there inside TCP, UDP, it's not there. I hope you are clear with these two. Okay, first, that is a session layer. If multiple windows of the same application are open, then in that case the data will be bifurcated according to session identification. Best example is browser. And then I told you that how to serve to the upper layer, this kind of funda, it comes from data link layer itself. Options field is there to identify network layer protocols. In network layer IP, we are having protocol number field to identify transport layer protocols. In transport layer, we are having port number concept to identify upper layer application protocol. And in that application, if we are having multiple instances, then session layer is going to bifurcate that. So this was a generic explanation. And then last, I told you that what's going to be the difference between TCP and UDP. Both the protocols work at the transport layer. There are few streams of data which are supposed to be programmed with UDP, but few type of communication has to go with TCP, like email. So it goes with the protocol called as SMTP. SMTP is having port number 25. Okay, but let's say there is a communication like DNS. It's based on UDP. Port number is 53. So different types of protocols are using TCP or UDP accordingly at the transport layer. Alright, so take it down entirely and we'll stop over here and we'll continue tomorrow in our next session.